Everyone, I'm super excited to be here and welcome to today's session. We are going to talk about transaction monitoring, navigating millions of records for effective context-based monitoring. So let's get started. First, I'm going to be joined by Thibaut for today's webinar. Hello, Thibaut.
Hello, everyone.
So Thibaut is Head of Customer Success at Linkurious. And as for myself, my name is Jean and I'm the Managing Director at Linkurious. So very excited to be there and to discuss with everyone today about transaction monitoring. So let's get started. First, maybe a quick few words regarding the company. Linkurious was created in 2013. We have two offices, one in France and another one in the US. We are a team of 50 plus employees, and we are serving more than 10,000 investigators and analysts on a day-to-day basis using all products to conduct complex investigations. You can see here some of our partners and clients. Among our clients, you can see Zurich Insurance, Her Majesty's Revenue and Customs, Pioneer Deliver Street, Ria Money Transfer, or Airbus, among others. And among our partners are companies such as Neo4j, Microsoft, Deloitte, Dataiku, PwC, and Capgemini. So let's say a quick word regarding today's agenda. It's going to be a webinar in three big sections. We'll start with how graph analytics can improve the transaction monitoring systems. Then we'll discuss how to use graph analytics for effective transaction monitoring. And finally, we'll do a bit of a demo, diving into how to specifically use Linkurious Enterprise to conduct transaction monitoring. So without further ado, let's get started.
Thank you, Jean. So we're going to start by exploring doing a bit of a, I would say, subject matter and exploring a bit what is transaction monitoring and also what are the current challenges in that field and how graph technology in Linkurious Enterprise can help improve transaction monitoring, transaction analysis. So we can start by a bit of introducing our the topic, the subject, what is transaction monitoring, which is the process indeed of monitoring a customer's transactions, such as transfer, deposits, and withdrawals. And as you know, and as I may say, financial institutions have become kind of like the auxiliary police of the anti-financial crime ecosystem today. And as such, they are under high scrutiny from the regulators in the way that they monitor, document, analyze, and take decisions on suspicious transactions. And the TMS, the transaction monitoring systems, are at the center of the anti-financial crime arsenals that financial institutions have built. And it is a strong regulatory requirements in that business sector, and that for the financial institutions that are under the money laundering regulations. As we see, have we seen recently failings in identifying, monitoring, detecting, monitoring, analyzing, documenting transactions, and significant gaps in transaction monitoring systems can lead to strong, strong fines, as we say. So the example of Danske Bank recently in December 2022 pled guilty and agreed to a $2 billion fine with the United States Department of Justice for failing to monitor and close multiple gaps in their TMS, leading to billions being laundered through their correspondent banking network. So as you can see, it's a very strong regulatory requirements, and is at the focus really it's a strong focus of financial institutions to have performant and relevant transaction monitoring analysis. However, we've seen that, as we would call the traditional approach to transaction monitoring, comes with some challenges and has some, I would say, has shown some weaknesses for different reasons. First of all, usually the traditional TMSs have too much focus on static rules and, as we would say, isolated threats, such as in a single pattern, such as how many transactions in the last X days. Is this in line with the specific client's past behavior? And those kind of analytics do not take advantage of a wider context that would allow to just make the jump from an isolated to a more extended network, for example. Generates usually too many false negatives. So smart criminals have long adapted to these controls and know how to bypass them, or to avoid detections long enough to succeed. So what we see is that those networks evolve usually faster than the static, I would say, topologies or classifications that banks use to feed their TMS. And as such, banks can generate some weaknesses, and also banks can be blind to certain kinds of dynamic evolving patterns. It also generates too many false positives, meaning that if you want to cast a net that is too large enough, you might generate too much false positive, and ML teams are spending too much of their thin resources chasing false positive instead of adapting to new threats and actually focusing and taking time to analyze properly the real threats. So let's see how can graph analytics, graph technology actually reinforce or help in those kind of weaknesses that we have identified in traditional transaction monitoring systems. First of all, the main value of graph analytics is adding contextual information to help spot the actual risk. So as we see, typically say an alert generated by a TMS would consist of, well, indeed, the financial transfer, the transaction between a company A and a company B, with some, I would say, first degree connections, such as the director of company A, the location of the company, and usually some limited information about also the financial counterpart. And with that limited context, it's really hard for an analyst to take an informed decision on whether or not that financial transaction is suspicious because it went over a set threshold. However, so in that circumstance, the financial transfer could be approved, where even if we actually miss some all the information about the surrounding the contextual environment around the both companies and the beneficial owners, for example. However, when you build a graph, you can easily, I would say, break silos, I would say, and reconciliate data across your whole organization. So leveraging data from other subsidiaries, for example, or just getting together a 360 view of your clients, the counterparts, and also the first degree, but also multiple indirect connections with your clients to really identify and build the whole context around your clients to have the full view around a say transaction. So in that case, you could see that we have the client and it matches with another client that is connected himself to a sanctioned entity. So by building that connections that could have been missed with that wouldn't necessarily been highlighted with a TMS, you get a full scope of potential threats and here connections with a sanctioned entity. So in that case, you have informed decision, you have a wider context that would allow you to consider that transaction as suspicious because of an indirect connection with a sanctioned entity. So consider that in that case, we have a pretty simple graph, but graph would allow you to very quickly, even in real time, identify indirect connection up to multiple hops of indirect connections with sanctioned entity, even very discrete connections within your organization, but also thanks to the flexibility of graphs, you can also incorporate data from third-party data vendors and data providers to also enrich your KYC data with third-party vendor to really expand that the context of your investigation. So grafting technology can help detect risks that will otherwise go unnoticed. As another example, usually TMS focus on, I would say, isolated threats, or what we would call outliers. So, for example, a transaction that would go above a certain threshold. But in focusing on the deviation from the normal transaction behavior of single elements, like here outliers, it ultimately results to only identifying isolated threats, isolated individuals, or sticking to only known static patterns that have been already identified in the internal risk classification of the financial institutions. Whereas with Graph, Graph allow you to actually dig deeper by detecting actually in real time suspicious relationship, discrete relationship within patterns of normal transactions behavior to really push the envelope on your investigation and have an extended context with a wide range of data points that can structure a network such as KYC information, digital footprints, application logs, and use all those data points to detect unusual connections, even with normal behavior. So, for example, to detect a evolving or forming smurfing pattern, for example, network, by using a wide range of potential connections. So in that case, yeah, transaction monitoring and graph analytics can really go hand in hand. So we call it a match made in heaven to really complement and reinforce your transaction monitoring arsenal by providing more effective investigations. So graph visualization makes it easy to understand the context around any situation and act quickly and confidently instead of wasting time chasing information. In doing so, it allows to reduce false negatives. So traditional anti-financial crime rules are bypassed by sophisticated criminals. And with graph analytics, you can uncover complex fraud and money laundering schemes as they emerge. And you can even add context to machine learning models. You can leverage graph analytics and graph embeddings to provide extra inputs to your machine learning models. So here are some like well-known financial crime, money laundering schemes and use cases as an example of how can we combine graph analytics to reinforce transaction monitoring, such as round tripping, mirroring, money mules, sanction evasions, AML investigation, or contextual AI. So, for example, you can also leverage the specific graph algorithm, such as centrality, to identify hubs within a network, to identify what are, for example, the collecting bank accounts that are collecting funds and dispatching them. Pathfinding algorithm to run like a follow the money queries investigation to identify the path of money flows within the network. How does it enter the bank? How does it exit the bank? Community algorithm to identify clusters of clients or bank accounts with, I would say, discrete relationships or types of relationship connections that most likely the anti-financial crime team weren't even aware of, but that can be uncovered through community algorithm. And even real-time querying. So what we've seen, we have some clients who actually make good use of the different data leaks like Panama Papers and those kind of data leaks. They use them and they run some alerts that can actually generate a match, an alert, as soon as a connection is fine, a match is fine between their data, their KYC elements, and elements from those kind of data leaks to identify potential sanction evasions.
Thanks, Thibaut. Now let's see how to use graph analytics for effective transaction monitoring. First, a quick word about our own vision at Linkurious. We provide a piece of software called Linkurious Enterprise, an investigation software. And it leverages graph analytics to do two things. First, detect suspicious patterns, and you can do that across billions of entities and relationships. But it also helps conduct accelerate investigations. Linkurious Enterprise can be combined with other best-in-class resources, such as graph databases, entity resolution technology, data providers. It can be done on an ad hoc basis based on the specific requirements of our clients. So all of this comes down to a very modular approach, which helps clients enhance their existing transaction monitoring systems based on their needs. So it's not a scratch and replace. It's really about adding specific value to an existing setup. So examples of that include the ability to add graph visualization capabilities to a TMS, for example. We have other clients that want to leverage graph analytics to uncover new risks. We also have clients that are interested in data quality, enriching the existing data with third-party data via entity resolution. And all of that can be done via the platform and much more. So you can see here what it looks like at a high level in terms of architecture. You can see the data on the left can be internal data, external data, can be both. It flows into the best-of-breed graph intelligence platform of Linkurious that provide capabilities such as entity resolution, alert linkage management, graph analytics, and search and visualization capabilities. All of that works together to help make more high quality and faster decisions. So that's all Linkurious really enables effective context-based monitoring of your transactions. Yeah. Thibaut, maybe you want to say a quick word about a specific client example?
Yeah, so a very dear client of ours, which is RIA, so the leader in money remittance across the world. So just an example of as to illustrate what actually Jean was talking about, and the fact that you really can reinforce and complement your existing arsenal consisting of a TMS solution and add on top of that Linkurious Enterprise in your graph database to really build a thorough investigation of suspicious, for example, remittance corridors. That's how they use it to detect complex graph patterns within remittance corridors. So the idea is that their challenge is that they're focused on basic thresholds, but generate some vulnerability against complex schemes like round tripping, money mules. And they were unable to get the full picture of high-risk customers, meaning that they get a match or they get an alert on the fact that this specific transaction is suspicious, but they weren't able to be confident on the fact that they really were catching the full context and all the stakeholders involved in that specific transaction. So the idea is that they pivoting from their existing legacy TMS, they pivot from the existing legacy TMS solution to Linkurious Enterprise to conduct investigation. And in doing so, they were able to reduce their investigation time for complex cases by 80%, because analysts were able to get all the relevant information directly in Linkurious Enterprise and get the full scope and get a confident decision. As well as, so it's one of our most advanced users also who make a good use of Linkurious Enterprise key features that Jean will illustrate further. So in the handouts, you'll have the case study of RIA if you want to look deeper into that case study. But it's a very interesting client making good use of Linkurious Enterprise for transaction monitoring.
Thanks, Thibaut. So in a nutshell, there are 4 big reasons to partner with Linkurious. First, it's all about achieving better decisions, and that's done via the graph visualization UI of Linkurious Enterprise, but also with that entity resolution capabilities that allow for higher quality data. And then there are also some collaboration features within the platform in terms of comments and the ability to share work with colleagues. Another big point is the ability to enhance the detection of risks and new risk typologies, and that can be achieved via the case management and alerts features within Linkurious Enterprise, but also via access to graph algorithms, node embeddings, and machine learning capabilities. The platform is also very flexible. There's an API that allows for the integration of new capabilities into existing tools and with existing processes. So as an example, we have clients that are adding graph visualization within their existing case management systems via the API. The architecture is also very modular. So we have clients that just want to have a graph database and Linkurious Enterprise to do some addection and investigation. Other clients will want to enrich that with advanced graph analytics capabilities with Neo4j HDS, for example, or with entity resolution capabilities with software such as Sensing. Finally, in terms of flexibility, we provide a very open data model, so it's very easy to incorporate new data sources, whatever your domain is. So we are discussing about transaction monitoring here, but we have clients that are using the same platform in a wide range of scenarios, such as supply chain analytics, law enforcement, investigations, and more. And finally, all of that comes in an enterprise-ready package. It can scale to billions of nodes and relationships with fine-grained security to make sure that your sensitive data remains secure, and the platform can be deployed on-premise or in the cloud, depending on your needs. So I'd like to illustrate a little bit what this looks like from a project perspective. So it all starts with the existing legacy systems where the data is stored. Can be internal data such as KYC information, transactions, but also the existing scoring data that you may have. This can be complemented with external data with information such as company registries, data from watch lists, or information about politically exposed persons. This data needs to be ingested. So if there are no big deduplication issues, because for example, it's just one big internal data source, then data can be pretty much loaded as is. It's very simple. If you're dealing with internal and external data sources, then entity resolution may be applied, maybe actually big requirement to make sure that the end result is high quality. Afterwards, you need to set up the graph database. The data at this point is loading into one of the graph databases supported by Linkurious Enterprise. So that list includes Neo4j, main graph, AWS Neptune, or Azure Cosmos DB. At this point, a lot of our clients are also using graph algorithms and graph machine learning to enrich the data with extra information. And finally, Linkurious Enterprise can be set up. So at this point, you can configure access rights, also configure alerts, create templates, and potentially also integrate that all of these capabilities into one or more of your existing tools. Once this is done, you can start the process of reviewing alerts and conducting investigations. So that's what it looks like in terms of a project, and our team can help you achieve that kind of outcome. But we also have partners throughout the world that can assist if you want to do such a deployment. Here we have a bit of an architecture example. So that's focused on an implementation of Linkurious Enterprise and Neo4j alongside an existing transaction monitoring system and an existing data science platform. So you can see on the left internal data such as KYC information and transactions that's flowing from a data science platform. That data sense platform is used to generate alerts that are processed in the case management system. And it's been augmented by pushing the data in the graph database, where extra analytics can be conducted to add some additional features to the data, graph features that can be leveraged to detect new potential issues. And another important aspect of the setup is that Linkurious Enterprise is connected to both the graph database and the case management system via the Linkurious Enterprise API, meaning that for any case that you open within the case management system, you can quickly pivot to Linkurious Enterprise to get a 360-degree view of what's happening, what's the surrounding of the client or of the transaction. So that's one example of deploying Linkurious Enterprise to augment an existing transaction monitoring system. So we've talked a little bit about transaction monitoring, graph analytics, and now what I'd like to do is give you a bit of a demo of what it can look like in practice. So in order to do that, we're going to use a fictitious dataset. So that dataset contains people, companies, transactions. It's been augmented via entity resolution with third-party data from open corporates. And together, during the next few slides, and then with the demo, we will see how to use graph analytics to risk score entities, to detect suspicious activities, and to conduct investigations. So let's get started. First, it's possible to leverage graph analytics to score to score risky entities at the entity level. So graph analytics can be used to apply basic scoring based on the attributes of an entity. So we have an example of that on the right with a graph query written in Cypher, a popular graph query language. So we see that we have a person, and when that person has a nationality that belongs to the list of Afghan and Syrian, we mark that person as we add a yes to the risky nationality attribute of that person. So that can help identify whether an individual is from a risky country, or if an individual is a PUP, or if this company has been registered recently or not. So these are examples of very basic analytics that are done, very much with a focus on the particular entity and its attributes. You can do that with graph, but that's really not where the added value of graph analytics here is. And I'm going to show you some examples of what can be done in terms of graph analytics. So now we are going to switch gears and not just look at the entities of interest at the individual level, but more at the network level. And that's really where graph analytics can shine, and where graph analytics is uniquely suited because it can help compute risks based on the context of an entity, not just what's happening, what are the direct attributes of that entity, but what's happening in the context of this entity. So a couple of examples of that. Maybe you want to know whether a company is connected to an address shared by multiple other companies, because this company is using registration agent potentially, and it can be indicative of a shell company. Or maybe you want to identify if there's a mismatch between the company's directors' nationalities and the company's country. Or maybe you want to know if a particular individual that you are dealing with is indirectly tied to a politically exposed person. In all of these situations, it's not just about what's happening for the particular entity, but it's more about the network of this entity and what's the surrounding of that entity. And graph analytics, once again, is uniquely suited for that kind of analytics. And you have an example of that on the right. We have a query that identifies the number of suspicious individuals within a person's network. So you can see up top that we are looking for persons that are connected to other persons across shared addresses, shared IP addresses, shared phone numbers, or the officership of a joint company. So all of different types of connections that can connect one individual with other individuals. We are trying to look at these other individuals and identify among them the ones that are politically exposed persons, the ones that have a risky nationality or a risky occupation. And then all of this is turned into a score. And at the end of the day, we are counting the number of risky individuals within the person's network and using that as a risk score, as a network risk score. So that's one example of using graph analytics to look at the network of a particular entity of interest to compute a network-centric risk score. And finally, graph analytics can be used to detect suspicious patterns. And we are going to give you some examples of that. So first, the entity and the network level scores, they can be combined together or with other indicators in a composite risk score. And that composite risk score will probably be have even more value than just the entity level or the network level risk scores. And very simply, entities with a high risk score can be flagged for review. And that's one very easy and simple way to add graph analytics to your existing processes just by using that as an input for an existing risk score. In addition, graph analytics can be used to detect specific patterns, such as money mules networks, round-tripping patterns, and more. On the right, you have a bit of an example. We are trying to identify instances of a company that's sending money to two other companies, where all the companies are actually controlled by the same directors. It could be a pattern indicative of money laundering, and it can be described and detected at scale with graph analytics. So we've talked about risk scoring. We've talked about alerts. Now let's dive into a demo of Linkurious Enterprise, and we are going to be connected once again to a fictional database of a bank. It contains KYC and transactional information, and we are going to investigate a series of transactions related to a potential money laundering ring. We are going to see three big things. First, we'll see how to monitor your data to detect suspicious patterns. Then we'll see how to investigate one particular suspicious case. And then we'll see how to share your findings with colleagues. So let's switch to the demo now. So this is the Linkurious Enterprise UI. Here I'm connected to a workspace that's shared with my anti-money laundering team. I can have multiple visualizations, multiple folders to facilitate the communication of findings with colleagues. Right now, what I want to talk about is alerts. So I'm going to go to the alerts dashboard. First, I'm going to talk about how to generate some alerts, and I'm going to show you what a specific alert looks like. So this is an example of an alert. It's called associated parties, and it's based on a graph pattern. It's actually the same exact graph pattern that I showed earlier on. So we are looking for a situation such as a bank account that's sending money to two other bank accounts. So that's described in this section. And then what we want to identify is when all of these bank accounts are actually interconnected across relationships such as the fact that the officers of the company are actually employed and working in the same companies. So it's as easy as typing that query in the Linkurious Enterprise UI, And then Linkurious Enterprise will monitor the data and raise an alert, a case, I guess, every time that there's in the data an occurrence of the pattern that we have just described. So that's what this looks like from the perspective of a data scientist. But what I want to talk about now is what this looks like more from the perspective of an actual investigator. And that investigator would typically connect to Linkurious Enterprise and look at the list of cases. That list of cases can be sliced and diced based on the alert types, based on the status of the alert. But right now I'm just going to go ahead and look at the latest alert. So I'm clicking on it now. I can see a bunch of information about that. I can see that it hasn't been assigned yet. I can see that the status is open. I can change that. I can assign it to myself. But right now I want to just open the case. Okay, so here we go. So we can see an alert, and it definitely matches the pattern that we have described earlier. So we have one bank account, which is right there. It's sending money, and that's a money transfer to this bank account, and it's also sending money to another bank account, which is right there. So one bank account sending money to two bank accounts, and there's nothing suspicious, nothing wrong about all of that. What's interesting is that at the same time, we see that this bank account belongs to a company called Parts Plus Auto Repair, which is associated with that director. And that director seems to be connected to another director of the same name. So it has been resolved via the anti-terrorization process as one and the same entity potentially. And that director is connected to this company called Silver In. Okay, and that company is connected to Ahmed Mehmet, who himself is connected to this Ahmed Mehmet, who controls the bank account associated with who controls the company associated with these bank accounts. And this company is actually apparently the same company as this one. I can see the source for all of this information. For example, here, Silver In. We can look it up in the Open Corporates website to see some extra information. And here we can see when we zoom out that we indeed are looking at a ring where these bank accounts are actually belonging to the same persons, because at the end of the day, it's Silver In, which is sending money to these companies that are controlled by this guy and these guys were directors of Silver In. And we wouldn't understand that if we were just looking at these transactions taken in isolation. We need to look at the broader context to understand that and to see that there's potentially something suspicious that's going on. We can actually dive deeper in the data. So I can click on these two bank accounts, see what they are connected to. So they are connected to some extra bank accounts. They are sending money to this bank account, this bank account, this bank account, and this bank account. So let's learn more about that. So I'm going to go ahead and select these four companies, these four bank accounts. Okay. And we have identified another set of companies. I can expand all of them. Okay. And we see some extra information. So, for example, Gobert Hub Ltd. It's been identified as a potential match with another company called Gobert Hub Ltd. And interestingly, this company seems to share a phone number with Big Impact Graphics Limited, which has been identified as a duplicate of this company. Okay, and now if we look, if we do the same kind of analysis with the other companies, such as Visionox. Okay, you can see that Visionox is also sharing a phone number with Foch Immobilier, which has been identified as a duplicate for Foch Immobilier. So we are, I mean, these four accounts that received money from the two initial bank accounts are actually interconnected to one another. That reinforce and this reinforces the suspicions that we may have. That visualization that we see on the screen may be a bit complex, and we have different ways to reduce the complexity here. For example, we can regroup relationships when there are multiple relationships between any two nodes. It's also possible to bring this data into a timeline to see, for example, the flow of money during as time evolves. So we can see the initial transactions. We can see the last transactions, for example. We can also slice and dice the data. Maybe what I want is to just look at the bank accounts. So I'm going to go ahead and do that. Select all the bank accounts. And I'm going to remove everything else. I'm actually going to use a different layout now, a hierarchical layout, just to get a different perspective on the data. And here we see the bank account, the bank account that's connected to Silver Inn, which is the initial company. So it's sending money to two other bank accounts. And then it's sending money to, these two bank accounts are sending the money one layer deeper in the network to four bank accounts. And we have seen that these four bank accounts are actually interconnected across information such as phone numbers. So it's really suspicious. All of the companies that are in that network are actually connected to one another, and the money is flowing through this network of companies. It could be indicative of money laundering scheme. So we have conducted that investigation with Linkurious Enterprise. At this point, we have different ways to report back on that. So we can save the visualization first. So we can also add some comments to the case that we've opened. Typing here, we can also mention colleagues in this part of the interface. So maybe I want Thibaut to know that I've uncovered something. So I'm going to go ahead and do that, typing a note. And I can also, of course, change the status of the case. Put it in confirmed, dismissed, based on what has been encoded. So that's it for a quick demo of Linkurious Enterprise. Together, we have seen how to use graph analytics to identify suspicious behaviors within our data set. We've also investigated one such suspicious behavior, and we've been able to get a good understanding of the situation to close the case together. So that's it for today's webinar. Do you have any? Let's dive into the questions of the audience.
All right, thanks, Jean and Thibaut, for the presentation. It looks like there's a few questions here, so yeah, let's go ahead and dive into those. The first one looks like it's a two-part question. It says, how easy is it to integrate your product with existing systems? And how does it work with other AI or machine learning platforms?
So how easy it is to integrate Linkurious Enterprise with other systems. So it's definitely, when the software is deployed, I guess a lot of times our clients, they already have an existing ecosystem of tools and processes. So that's, I would say, bread and butter to integrate with that. And we can do it via an API, typically, that allows for the use of Linkurious Enterprise as a standalone app, I guess, but also directly, as something that's embedded within your existing apps. So we have clients that are using products such as Pega, Appian, case management systems, and these tools can be enriched with visualizations powered by Linkurious Enterprise, just like we can push extra alerts to these systems. So that's it. In terms of how the platform can be integrated with AI or machine learning tools, something that we are seeing quite a bit in the market is that there are extra features that are computed at the graph database level. Could be a simple feature as simple as what's the number of risk entities that are connected to a given entity. Or it could be things such as the PageRank algorithm that would be used to compute a PageRank for a node. And these extra features, they are pushed to the machine learning platform, and it's just extra information that's used in the machine learning model, and which drives the accuracy of the machine learning predictions.
All right. Next question here. Is your solution turnkey, or do we need to already have a graph database?
So having a graph database is a hard requirement to deploy Linkurious Enterprise. You do need to have a graph database. Ingesting data in the graph database and deploying graph database is definitely something that we can help with. It's not a long, complex process, I would say.
Okay. Next question here. Do you have a tenant setup? Multiple clients can use the same engine and DB, or it needs to have one install per data set?
So you can have one single Linkurious Enterprise instance that's connected to multiple graph databases, and you can also manage access rights within Linkurious Enterprise to make sure that your users they don't necessarily have access to all the databases. So that's definitely something that can be done, and then we provide the ability to our clients to deploy on premise if they want. So you can also help with security.
All right. Let's see, next question. If there is a bank operating on-prem system, will it be possible to implement graph analytics without using external graph databases?
No, once again, having a graph database is a hard requirement for Linkurious Enterprise. And the reason for that is that it's really a game changer in terms of both the ability to conduct graph analytics scale, but also in terms of the ease of doing that. Yes, we showed some examples of basic query patterns. Doing the same thing in a non-graph query language can be a bit of a nightmare.
All right. Next question. Is Linkurious Enterprise available as a SaaS solution?
Yes, it is. It's a possibility. If you want, for example, to do a quick trial, the SaaS option can be a good approach.
All right, there's another question coming in. Does the approach work effectively with monitoring against sanctions, and what are the exact benefits?
Sure. So we have clients that are doing sanction monitoring for sure. It's just it's all about bringing into the mix sanctions data. For example, we have good partnerships with a company called Open Sanctions, which provide such data. It's just one example of a data source that you can bring into the platform to unlock that specific use case. In terms of benefits, the big benefit is that you can there are multiple benefits. First, you can identify risks related to a sanctioned entity that are deep in the network. Maybe that one counterparty that you have is not on the sanctioned list, but some of its related parties actually are. And being able to identify that is going to help you better assess that risk. So there's that. And the platform can also help with enriching the data. And even if that particular client of yours isn't on a sanctions list, it's not necessarily easy to identify that. And with the use of entity resolution, you can get access to that information. At the end of the day, it's about being able to more effectively identify the connections between your clients and sanctioned entities.
If I may add something here to specifically if you're one of the tasks before even when you're trying to map your sanction exposure to sanction is the actually identify beneficial owners of complex ownership structures. And we have clients, for example, who work in private banking and they deal with complex ownership structures and different layers of company, and graphs really help them to first build that full 300 exhaustive view of the company, really identify and query very quickly to identify the beneficial owners of those companies, and to make sure that when they screen the sanction, they are really screening exactly the full scope and the full view of basically the company to deal with, the counterparts of the transactions, to make sure that they are identifying really the beneficial owners and they have this full view identified as a graph when they trying to match that with a sanction list. So definitely yes, and the fact that it helps you to have this exhaustive view of complex structures and beneficial owners.
All right, thanks. Next question. Can the system be shifted to the left and be used as a screening tool before transactions are processed?
For sure. So we have some clients that are doing that. Maybe Thibaut, you want to talk about this one?
It's an interesting question. So being used as a screening tool per se, like Actimize or I'm not sure about it, but basically it can definitely, if you think of a process where upstream you enrich your data, KYC data, claim data with sanctions and PEP list, a politically exposed person list, you can definitely use like entity resolution matching logic to build that graph, identify the most like discrete connections between your clients and elements within a sanction list. So the address of a sanctioned entity, etc. Build those connections to make sure that you have that matching. So use basically the power of the graph data model that is really the most powerful solution to identify connections and discrete relationships, and then make sure that your screening is performed really on an exhaustive basis. So in that sense, you could say that you can use a graph data model as a screening tool, in the sense that you can really build this relationship through the graph data model between a sanctions list, a list of sanction entity, and your client database. I hope that answered your questions. It was an interesting question.
Thank you, Thibaut. Looks like there is one more question here. Can the same capabilities be used for other industries beyond financial services?
For sure. So we have clients that are using the same capabilities and that also need to do sanction screening. For example, we have clients in the industry that are very much concerned around export controls regulations, and that ability to leverage data and connections to understand if their suppliers or their clients are somehow connected to Russian entities, for example, or Chinese entities. That's very important, very relevant. We're also working with law enforcement agencies that are looking at things such as tax fraud, among other use cases.
All right. It looks like that's it for questions for today then. We did record this webinar, so we will be sending out the recording as soon as it's available. But of course, if you have any questions in the meantime, you can visit us on our website and reach back out. So that's it for today. Thank you all for joining, and we do hope you enjoyed this webinar.
Thank you, everyone.
Thank you all.